Thank you very much, Fernando, and welcome everyone. Just before we start, let me say 2 words about who we are. The Regulatory Assistance Project, or RAP in short, is an independent, non-governmental organization, a group of experts dedicated to accelerating the transition to a clean, reliable, and efficient energy system. RAP's advisors come from different backgrounds in utility and environmental regulation, industry, system operation, and other policy areas with experience in the power sector. And our team focuses on the world's 4 largest power markets that are responsible for half of all power generation: China, India, the United States, and Europe. And that's where this webinar was created. So today's webinar will be all about the integration of electric vehicles. And as you know, worldwide electric vehicle sales are increasing quickly, and their benefits in terms of air pollution reduction, CO2 reduction, and energy efficiency are well recognized. But in addition to that, they have significant power system benefits that can only be exploited if we put the right policy framework in place. And today's webinar will discuss how smart pricing, smart technology, and smart infrastructure in particular can make EV grid integration beneficial and cost efficient. And our webinar is based on a study published earlier this year, also available on our website, and where our aim was to identify promising practices of EV grid integration that benefit consumers and that are already existing today. So today's webinar will follow 3 parts. By ways of introduction, we first discuss the opportunity of integrating EVs into the grid in more detail. We'll then discuss promising practices of EV grid integration and consumer benefits, mostly around Europe. And we'll conclude with some policy recommendations from our analysis. So what's the opportunity of EV grid integration? And why is it so important we get it right? EVs help to reduce emissions in several ways. Fundamentally, they are more energy efficient. They use about 1/3 of the energy of a comparable combustion vehicle. From a transport perspective, locally, they're needed in cities to reduce urgent air pollution problems. And here, of course, they're only one ingredient of a larger shift towards a cleaner transport system that relies on public transport and other cleaner modes. And globally, EVs are also needed to reduce CO2. In Europe, for example, the transport sector is the only sector in which CO2 emissions are still growing. And the graph you can see on this slide is from the IEA's 2019 EV Outlook. And it shows that the EV fleet expected in 2030, based on existing policies, will avoid about 220 megatons of CO2 equivalent. Now, in comparison, a vehicle fleet made of combustion vehicles would almost double these emissions. And of course, the carbon reductions that EVs can deliver are even higher if more zero carbon electricity is used to drive them. But EVs don't only have environmental benefits, they also have cost benefits for consumers. The total cost of ownership of EVs is becoming competitive. This graph shows data from 2018 and shows total cost of ownership of a purchased EVs is still a little higher than that of diesel or petrol cars today. But as you can see on the right side of the graph, in case of a leased EV, they are already competitive today over the total ownership period. And this is a study that was done for the European Consumer Association that in an earlier version also showed that EVs are going to become fully cost competitive in the early 2020s. And because EVs are cheaper to drive, they can decarbonize transport, and they can use cleaner electricity, they present a great opportunity for the power system itself to decarbonize. And this is what we're going to focus on today. So what are the grid benefits that we're talking about? And how can they benefit consumers? EV charging can be shifted to hours when it's better for the grid, and we'll explain exactly what that means further on. For example, a privately used EV is not driven for about 90% of its time, and that flexibility makes an EV an enormous resource for the power grid. That flexibility can also be used to help integrate increasing volumes of variable renewable energy sources. And EV's flexibility helps system operators to manage the grid. Doing so, they can reduce system costs, so less cost has to be shared overall among electricity users, and it lowers our electricity bills. And here is where EV grid integration creates benefits for all electricity users and not just EV drivers. To make sure we reap these benefits, charging EVs smartly is absolutely key. And by that, we mean shifting charging to times when costs for electricity are lower, without compromising the vehicle owner's needs. So why is this so important? First, it empowers consumers to improve their charging behavior and be in control of it. And second, it helps to save money. At present, most electricity consumers have flat electricity tariffs that do not give them any incentive to charge at specific times. And what happens with unmanaged charging is illustrated in this graph. The curve you can see here depicts the load curve in a big distribution area in Germany on a recent peak day. And it shows a clear morning and evening peak. And the red curve shows how this evening peak would increase if all EV users plugged in their EV when coming home. And first evidence from Europe's most mature EV market, Norway, shows that that is exactly what happens if we do not set incentives to consumers to shift their charging. And how that could look like is illustrated by the green curve. We want to shift charging to hours when it's better for the grid. For example, to night hours when electricity is cheaper and most likely cleaner. And how exactly smart charging helps to build in renewables, Christos will explain in more detail.
Thanks, Julia, and welcome to everyone. So, as Julia already mentioned, EVs have significant inherent flexibility. Vehicles tend to be parked for the bulk of the day, some 21 to 22 hours under the private ownership paradigm, and at the same time they only need about 3 to 4 hours to fully charge using a 7 kilowatt charger. What that means is that an EV requires only a fraction of time to fully charge during the time that it is parked. Due to this inherent flexibility of EVs, their charging could be directed when the sun is shining in the middle of the day, or when there is plentiful of wind generation available on the grid, instead of charging at times of generation from dirtier sources. Charging at times of significant rest production can help to integrate rest into the grid at lower cost and save consumers money. In addition to helping integrating renewables at lower cost, EVs can also help system operators to manage the grid. This graph shows the famous Californian tag curve, and what it shows basically is that as solar deployment increases on the grid, the net load decreases significantly at the middle of the day. As the sun is setting later on in the afternoon, the net load increases very rapidly, and this is one of the key challenges that system operators are already facing or will face in the future. Now, what one can do is to shift the charging of EVs towards the middle of the day. In this way, the net load increases and the wrapping requirements for when the sun is setting are decreasing. In this way, the system operator can reserve less resources and save consumers money overall, while also charging EVs with cheap renewable energy. And with this, I'll hand back to Julia to explain how we can realize these opportunities.
So after this introduction on the benefits, let's dive into the core of our talk today. And we will start. So we've identified 3 key ingredients to make EV integration more cost-effective and beneficial. First, smart or more cost-reflective pricing to encourage consumers to charge when it's better for the grid. Second, smart technology to make it easier for consumers to reap the benefits of smart pricing. And third, smart infrastructure located in a way that meets grid needs as well as consumers' charging and driving needs. And we'll explain what each of this area of opportunity is in more detail. And we'll start with smart pricing.
And so what we mean by smart pricing is basically that time-varying electricity prices for both the energy and the use of the network that are cost reflective. And with time-varying prices, one can direct charging towards cheaper hours. So for example, where there is ample network capacity on the grid. In this way, consumers can save on their bills and at the same time they can reduce the total system cost, thus delivering wider benefits to the entire consumer base. For example, by shifting charging towards the night hours, one can use existing network infrastructure and avoid an incremental cost for new infrastructure. And before we get into specific examples, just a quick reminder of the electricity bill. This graph shows the breakdown of the electricity bill as of 2015 for the average European household. This graph would have hardly changed in the recent years. And what it shows is that the energy component, the cost for generating electricity, are about a third of the total bill. And the network costs, the cost for delivering this electricity to the final consumer through electricity lines and cables and other assets, are just over a quarter of the bill. The rest of the bill is for taxes and levies. For today's webinar, we will focus on the energy and network components of the bill. And the first example of smart pricing is the simplest form of time-varying tariff. It's a day and night time of use tariff, and it comes from Spain in particular. This is an EV dedicated tariff offered by Iberdrola, and Iberdrola is offering a discounted night charge, which is about 80% lower than the day charge, as it's depicted by the blue bar on this graph. This sends a very strong signal to consumers to charge their EV during the night hours. For example, a Nissan Leaf owner that does around 10,000 kilometers per year and charges only during the night hours can save about 170 euros per year compared to a consumer that is on the standard flat rate of the company, which is depicted with a dashed line on this graph. Time of use tariffs can already offer significant benefits for integrating EVs cost effectively into the grid. Now, as we are moving towards a more decarbonized power system with more variable renewables and a more electrified transport sector, more dynamic tariffs can deliver greater benefits for consumers and the power system as a whole. This next example is coming from Great Britain and from a supplier called Octopus. Octopus is offering an EV tariff that is called Agile, and it's based on the retail prices are based on the half-hourly prices as these are determined in the wholesale market at the day-ahead stage. The company communicates the applicable rates at 4 p.m. of every day for the following day. In this way, consumers have sufficient time to adapt their charging behavior. What this graph is showing is the charging behavior of consumers prior to signing up to the tariff, the red line, and after, the green line. And what it shows is that consumers have shifted their charging towards the night hours. The supplier estimates that a consumer on the Agile tariff saves on average about 150 euros per year compared to a consumer that is on the standard flat rate. So the previous two examples focused on the energy component of the bill. And while the energy component sends signals about the cost of generating electricity, they don't send any signals about the state of the network. And as we saw earlier, network costs are about a quarter of the bill, therefore a quite important part of it. For this reason, it's important that the network charges also send appropriate signals to consumers about the state of the grid, and for this reason they should be time varying as well, to make sure that consumers are using existing infrastructure to the best possible extent. This promising example that we're showing on this slide is coming from Denmark, and more specifically from a distributed system operator that is called Radius, that serves 1 million consumers in Copenhagen and the surrounding area. And Radius has introduced time of use tariffs for households and commercial consumers that have a smart meter in place in recent years. The tariff on this graph is for households in particular. And the tariff is split in two seasons, the summer and winter season, whereby the winter season is from October to March. And for the winter season in particular, the company has applied a peak charge for 3 hours per day. These are the 3 highest demand hours that the company is seeing in its jurisdiction. And in this way, the company is trying to shift consumption away from these hours and towards other hours in order to minimize any expensive reinforcements on the grid, and also to make sure that they make best use of what is already existing. So now we'll move to the second element that we have identified, that of smart technology. And first, what do we mean by smart technology? In its simplest form, smart technology can monitor real-time or close to real-time consumption of a consumer and can communicate this information to them. The consumer or a third party can take this information and adjust their consumption accordingly. In a more advanced form, smart technology can automatically control the consumption of a consumer based on a set of criteria. For example, prices or the emissions profile of generation at the time. In this way, it can optimize consumption, for example, for EVs. The graph on this slide shows average peak reduction achieved for a number of smart pricing pilot problems from across the globe, with and without smart technology. And there are two key conclusions that one can derive from this graph. The first one is that consumers do respond to prices, as it can be seen by the different levels of peak demand reductions that have been achieved. And the second one is that consumers benefit the most when smart prices are complemented by smart technology. And this is also working the other way around. And before we go to the next key strategy that we have identified, just a short example of smart technology that is coming from the Netherlands and a company called Jetlix. Jetlix is offering smart technology coupled with a smart application. The driver enters their needs into the application. So for example, what time do they have to leave their house and for how long do they need to use the car? And the technology estimates when is the best time to charge the car based on electricity prices and the availability of sustainable energy. Overall, the technology is trying to shift charging towards hours of cleaner energy. And technology overall can help to reduce consumers' bills, make sure that they don't charge at times of high electricity prices, and achieve cost savings overall. And with this, I'll hand back to Julia.
Thank you, Christos. So far, we've discussed how smart pricing and smart technology can accelerate beneficial grid integration. Now let's turn to the third area of opportunity we've identified, smart infrastructure. And by that, we mean smart siting of infrastructure that makes it grid-friendly and cost-effective for the system and for consumers. The build-out of charging infrastructure requires tailored solutions because as the EV market grows, different use cases emerge. And they can range from electric taxi fleets needing fast charging to do a lot of kilometers, to electric delivery vans for city logistics, or private EVs, but that need to rely on on-street parking only. So the questions to consider for governments and planners are, for example, what is the best location to meet mobility demand? But at the same time, what is the best location to use existing grid or street infrastructure to reduce cost? And which kind of charging infrastructure is actually needed to allow optimized charging? So let's look at a few promising practices we've identified. The first and most obvious use case for smart charging are workplaces and multi-unit dwellings, that is multi-family houses, where most of tomorrow's charging is likely to take place. And these locations are very suitable to integrate EVs beneficially into the grid for several reasons. They offer an existing electricity network, as they are often located in dense areas. The cars are parked typically for long office hours or overnight, and that provides the flexibility to optimize timing of charging during these hours that are often off-peak hours. And that can help to absorb renewables, for example, strong wind power during the night or solar generation during midday, as we've explained earlier. And EV owners or companies with large EV parks can be encouraged to enable smart charging with time-varying tariffs. Or where a larger number of EVs are parked, automated technologies such as load management solutions can help to optimize that charging and reduce cost. And as far as charging in public spaces is concerned, a good planning practice for cities is to use existing infrastructure. And by that, I mean grid and street infrastructure to reduce cost. And an interesting example can be found in London, and you can see it on this slide. The city appointed an infrastructure supplier to convert public light poles into 3 to 5 kilowatt charge points for charging where people need to park over longer time periods. And one of the reasons to opt for this solution was the simple lack of space on the sidewalk, and of course cost reduction. According to the supplier, the cost per charging point could be reduced by several £1,000s per unit. And there are additional efficiency benefits to make. One district replaced the traditional, rather inefficient light pole bulbs with an LED light, so that they could use the excess power to help charging the EV's battery. So integrated planning is essential for smart infrastructure siting for cities. And this example shows that it should be based on consumers' demand. What you see here on the slide is beautiful Amsterdam, where the municipality builds EV charging infrastructure upon citizens' request, according to certain criteria such as minimum distance, and it also takes into account optimal locations from a grid point of view. And this practice, this demand-driven planning practice, helps to address siting uncertainties, so to better know where to locate these charging points. It also helps to plan infrastructure in a coherent manner as a municipality, and it creates knowledge and transparency to optimize infrastructure build-out for the future. In fact, Dutch EV charging infrastructure rollout has been documented since its early days by a research institute who created one of today's largest publicly available data sources on EV charging behavior. So it is possible to understand and learn from how drivers use these charging points. But what other options do planners have when seeking the best location for charging infrastructure? And the last example you can see on this slide in this section is to illustrate that in some specific cases, for example, when using existing capacity is too expensive, infrastructure may be needed that is not constantly connected to the grid and independent of peak times. And that's where battery-based fast charging can be used, or battery-based high-power chargers can be used. And of course, the very sharp decline in the cost of batteries and also the increasing availability of already used batteries make this combination very attractive. So this is a ferry by Havyard in Norway, who just went to production with a series of purpose-designed battery electric ferries. And there are more and more electric ferries in coastal regions, and some use battery-based charging systems. And how do these work? For example, an electric ferry operating between two sides of a fjord, of a coastline, charges fastly from two battery buffers at each quay when it is ashore for about 10 minutes, the time to take new passengers. And these port batteries charge from the grid in much slower mode while the ferry is away, and avoiding overload the grid in this way. Battery-assisted fast charging is also experimented with in the automotive world, and that includes using Second Life car batteries to assist fast chargers and moving battery-assisted fast chargers around, so taking advantage of the mobile characteristic of a battery, to locations with most demand for shorter periods, for example, to supply charging solutions to large events. And you'll find more examples in our paper, but let's now get to the final part of today's webinar, our policy recommendations, and I'm handing back to Christos.
Thanks. And our policy recommendations are for Europe in particular, and we're using existing EU legislation as the starting point. We're not going to get into any detail about the existing EU legislation, but we are happy to answer any questions that you might have during the Q&A session. So in relation to smart pricing, we believe that it's important that member states implement the clean energy for all package that was only recently adopted. This means establishing well-functioning wholesale markets that reveal the true value of flexibility to consumers, and establishing competitive retail markets where this is not the case. Now, going into more detail, in terms of the energy component, we believe that a competitive retail market will deliver the kind of smart pricing designs that can benefit customers, as demonstrated in European countries with well-established markets such as Great Britain and the Nordics. There might be, though, a couple of cases where regulators might need to intervene and set EV tariffs themselves. The first case would be in where regulated prices is the norm, and the second case would be where the market itself does not deliver the kind of tariffs that are expected, for example, because of lack of effective competition. In terms of the network component, we recommend that regulators require network companies to set time-varying tariffs for flexible loads such as EVs. What is very important is that regulators and network companies alike monitor the effectiveness of the tariffs that are in place. This is going to be a long trip, and it's very important that along the way we understand what is working and what is not working for consumers. Now, in relation to smart technology, our recommendation is that any electric charging solution is required to have smart functionality. And this could be the charging point, a cable, or the EV itself. Basically, what this says is that there should be technology in place that enables the application of smart retail tariffs. As we saw earlier in the presentation, you can maximize the benefits of smart pricing when you complement it with smart technology. And one way that you could do that is through national legislation that defines minimum technical requirements to drive deployment of appropriate technologies. An example of that is from the UK, and it's called the Automated and Electric Vehicles Act of 2018, that requires a set of minimum technical requirements for new charging points. Competition in the charging services market segment will help to deliver user-friendly solutions for customers, and we are already seeing this happening. And with this, I'll hand back to Julia to talk us through smart infrastructure recommendation.
And with regard to that last area of opportunity, smart infrastructure, there are several opportunities that exist for policymakers to improve coverage of charging points with convenient and accessible charging. First of all, thinking of the use cases that we urgently need to address, such as charging at workplaces and multi-unit dwellings, European member states have the opportunity to better equip these places by going beyond the minimum requirements of the current legal framework, the so-called Energy Performance of Buildings Directive. But this similar requirement could also apply to building codes in other regions. Governments can also do more to accelerate rollout of public charging infrastructure by implementing current European legislation more ambitiously. The so-called Alternative Fuels Infrastructure Directive allows governments to set certain targets to infrastructure rollout, and these need to be high enough and include future use cases. And an opportunity is certainly also that this directive is likely to be revised in the coming years. More generally, setting up integrated planning processes is needed, and these need to take into account transport, grid and user needs. And that's key for governments, but also for cities. And one practical way to explore what will be needed in terms of infrastructure for the future is to run pilots. For example, testing how electric vans or trucks will integrate in a transport system and what infrastructure is needed. Last but not least, as a principle, in all cases, smart infrastructure planning requires to explore how renewable energy sources can be best integrated in charging electric vehicles. And for more details on all of these recommendations, I'll refer you again to our paper. And with that, we're coming to the conclusion of today's webinar. First of all, we want to thank you for having had the opportunity to discuss the benefits of smart charging, the environmental benefits and the consumer benefits. We note that EV grid integration is needed and advances the clean power and transport transitions in parallel. We've also noted that policymakers on European, national and local level can address and should address this opportunity jointly. And we recommend to start with smart tariffs, smart technology and smart infrastructure. And with that, we're at the end of our presentation, and we want to thank everyone for listening to us today, and I'll hand back to Fernando for questions.